This tune is asking you to explain the difference between an arc and a sector. And my big hint for you is just look at where the arrows are pointing. Pause your video now so you have a chance to think about that answer. Alright, so basically with these answers, it should be pretty clear that the sector is pointing to the inside. That's a major sector right there. And we'll get to the major versus minor in a second. This right here, this yellow piece, is a minor sector. Now with an arc is just pointing at the edge. So, the minor arc right here and the major arc right here are just the edges around the circumference. So there's a lot of ways you could have answered. You could have answered in some of those words. Also, one thing to know is that an arc is one-dimensional. It just has length. You can only measure it that way. Sectors are two-dimensional, and you measure them in area. Today, what we're going to focus on is we're going to look at arc length. We're going to find out how to calculate that. Tomorrow, we're going to do sector area. Or not tomorrow, but in 2 days. You get the idea. So, one other thing that's important here, the difference between major and minor. If it's a major sector or a major arc, it takes up more than half of the circle. So like a major arc, the measure of it would be more than 180 degrees. And a major sector takes up more than half of the circle's area. With a minor, it would be less than half. So, as I just mentioned, what we're going to do today and Tuesday is look at arc length. Wednesday and Thursday, you guys are going to do sector area. And then we just have one little thing on chords. And then you guys have a project coming up next week because it's pretty much the end of the year. So what we're going to do right now is we're going to find the length of arc AB. Now there's a slightly different naming convention here. We had already found the measure of arc AB, and the measure of arc AB is the same as this angle measure. It's 165 degrees. But if we're finding lengths, what we want is we're going to use a unit like meters in our case right now. So here's the way you think about it. An arc is really just part of the circumference of the circle. So we know that the circumference is 2 times pi times the radius. Now we have to figure out what part of the circle do we care about right now. And the real key with this, the hint, is that it uses the angle. So like this angle is 165 degrees here of the whole circle. So to figure out what part of it is, we're going to take the angle measure divided by 360. Because the circle is always 360 degrees. And for our case right now, our angle, we have 165 out of a possible 360 degrees. So, you're going to take the angle divided by 360. Of means multiply. So times the circumference. Basically, here's the circumference. Here's how you figure out what little piece that we care about. So, in our example, the angle is 165 over 360 for the whole circle. And the 360 won't change, that's the same, times 2 times pi times the radius, which in our case is 2.4. So now you go to your handy-dandy calculator, and your answer is 6.91 meters if we're rounding it to the nearest hundredth. So arc length, they're all going to use this formula. Make sure you copy down this formula, use this formula. This is how you get the arc length. It's just a piece of the circumference. So you use the circumference, and then you multiply that times whatever proportion of the circle your angle takes up. So work on a few questions of finding the arc length, and then afterwards explain your process for finding it. What did you find? What were some shortcuts you used? How did this become easier for you?